This experiment is about superposition theorem, and in the theorem it is said that the current in the branch is due to the component current supplied by the all the sources in the circuit. That this current I sub 1 is a result of the current due to E1 and E2, and also I2 is due to E1 and E2, and I3 is due to the current from E1 and E2, meaning these currents are net currents due to the component current supplied by all the sources in the circuit. These component currents can be determined by allowing the current, or allowing a source, a single source, say source E1, to supply the necessary current for the circuit without the other sources in the circuit. And that is by deactivating all the sources in the circuit, in this case, deactivating the source E1. If we deactivate the source E1, then E1 would supply the necessary current for the circuit, and these currents are the component currents due to E1. And let's say this current I sub 1 prime is the current for branch R1. The I sub 2 prime is the current for branch R2, and the current I sub 3 for the branch R3. And these currents may be determined by simply reducing the circuit into a single resistance, and current is calculated simply applying Ohm's law and series parallel connection. So current E1 voltage E1 would supply the current I sub 1 prime, which is the total current, and this would be divided into two, that is I sub 2 prime and I sub 3 prime. Now, if we now consider the source voltage E2 and deactivate E1, the source voltage E2 will supply its own components currents, and this would be directed towards the direction of the opposite to the direction of the current supplied by E1. We have here the I total double prime representing the current going to R2. And in this case, this is the total current supplied by E2 and shall be divided in the R1 and R3. And let's name the current towards R1 would be I1 double prime, and at the branch R3 would I3 double. So these are the component currents due to E2. Now, these currents may be calculated again by simple circuit reduction applying Ohm's law. After calculating these currents, we can now determine the current in the branches when E1 is present. So when E1 is present, when these two sources are present, their components currents simultaneously exists in the circuit, there would be currents that would oppose with each other and current that would be along the same direction. Then to get the current in the circuit or in a branch, we shall consider the net current in the branch. The component currents of E1 is I sub 1 prime. This is R1, this is R2, and this is R3. And this is I sub 2 prime is due to E1, and this is the I sub 3 prime. Now the component currents due to E2 would be on that direction going to the left, I sub 2 double prime, and this is I sub 2, I sub 1, I sub 1 double prime due to E2, and the current at resistance R3 is I sub 3 double prime. We can see that if these currents would simultaneously exist in the circuit, I sub 1 and I sub 1 prime and I sub 1 double prime are opposing currents, and therefore the net current would be the current in the branch. That is why to calculate for I sub 1, it would be I sub 1 prime minus I sub 1 double prime. Considering that I sub 1 is larger than I sub 1 prime, simply because this is the I sub 1 is the total current supplied by 1. Now for the branch of R2, I sub 2 would be equal to I sub 2 prime, considering that I sub 2 would be larger than I sub 2 double prime, would be larger than I sub 1, I sub 2 prime, simply because I sub 2 prime is the total current supplied by E2, and that would be higher than the current I sub 2 prime, which is far from the source E1. However, the current in the branch R3, the component currents are on the same direction, and therefore these currents combines with each other to form I sub 3, or the current in the R3. So this is I3 prime plus I3 double prime. And this is the concept of the superposition theorem. In your experiment, you will connect the model circuit for this for the study of this theorem. We have the voltage B1 equal to 15. Set the voltage at 15 volts, and B2 at 15 volts. The resistances are known, and these are the ammeters. The ammeters, we expect the current 15 volts B2 to supply current, and also 15 volts B1 would supply current. So that is why the positive terminal of the ammeters are connected to the positive terminal of the supply. For this run, it will measure the net current in the branch. It is the the resulting current due to the voltage source B1 and B2, and you will record that in table 7.1. So for trial 1, both sources are 15 volts and allow these 15 volts to supply their current, and the resulting current in the branch of R1 and R2 will be recorded. So our concern here is the current in R1 and R2, simply because the current in R3 can be determined by simply summing up the I1 and I2. So after recording the I sub 1 and I sub 2, as the circuit is run in the multisim software, you will now consider deactivating the source E1 and allow the deactivating the source E2 and allow the component currents of E1 to exist in the circuit. So to deactivate the B1, so simply remove the source B2, deactivate B2, sorry. To deactivate B2, remove the voltage B2. By the way, you have to ground this. Remove the B2 and then connect the terminal from where B2 was removed to complete the circuit. And since we have only one source, B1, we have to change the polarity of this ammeter. So this would become, the polarity should be interchanged, because we expect the current to be coming from B1. So therefore, this should be positive terminal and this should be negative terminal. And the component currents due to B1 would flow. And this is the I1 prime. And here is I2 prime. And you would record that for component currents due to E1, I1 prime and I2 prime. Again, still for 15 volt source. So what you will do now is to deactivate the voltage source B1 and return the voltage source B2. Remove the short circuit, return the 15 volts. Here you have to, after removing B sub 1, connect the open terminals to complete the circuit. So this time B sub 2 would supply its component currents in the direction towards the position of B1. And so therefore this would be I sub 2 double prime, and here would be I sub 2 double, I sub 1 double prime. And you have to return the polarity of the ammeters, ammeter 2. This would now be positive and this would be negative. Now you have to interchange the polarity of the ammeter 1. This would be positive and this would be negative. This is simply to, in actual circuit, simply not to damage the ammeter by reversing the current into the coil of the ammeter. But in software, what you will expect here is the reading of negative values. You may not interchange the terminal, but expect that the reading would be negative. So you will record here the reading of the ammeter 1 and reading of ammeter 2. These are the component currents due to E2. In trial 2, you would reduce the voltage of the E2 to 5 volts. So these 15 volts would become 5 volts and maintain the 15 volts. And you would do the same procedure as done in obtaining the reading of the ammeters when the 15 and 5 volts are present, and then deactivate the 5 volts and allow the 15. Since it is the same with run 1, you will just simply copy the component currents due to E1 to trial 2. So whatever the current obtained in trial 1 for E1, that would be the same current, component currents due to E1 in trial 2. And so therefore, what you will need now for trial 2 is to deactivate the 15 volts, and allow the 5 volts to supply the necessary current for the circuit. And the ammeter 1 and ammeter 2 reading would be the reading for I sub 1 double prime and I sub 2 double prime, which are the component currents due to E2. You would be required to plot the graph to see the effect of changing voltage on the other side of the circuit. So you are required to plot on the 15 and 5 volts variation of E2. So this is a plot of voltage E2 against the changes in currents in the circuit. So you plot the I sub 1 and I sub 2. I sub 1 I sub 1 and I sub 2 double prime, these are the component currents due to E2, and the net current in the circuit for trial 1 and trial 2. The branch currents. So the branch currents is here. Here is the branch current. At 15 volts, we expect that I sub 1, say I sub 1 would be 1. At 5 volts, we expect that the current would increase, say 2. However, in I sub 2, we can say that this would be, say this would be at some value, say 0.5, we expect the current in when the voltage E2 is changed to 5 volts, we expect the branch current here to drop, say 0.5. These are hypothetical values. Hypothetical. So the values are hypothetical values. May not happen in the actual circuit, but this would be the trend to be expected in the experiment. Now, how shall you plot the graph is my concern. So at 15 volts for I sub 1, it is 1 ampere. It is somewhere here. Now, at 5 volts, the I sub 1 would be 2 ampere. So it will increase. The trend is it would increase, meaning if you decrease there is a decrease in voltage in one side of the circuit, then the tendency for the current supplied by or the tendency for the current in the circuit in the branch of I1, which is near the source B1, the current would increase at 5 volts of E2. However, in I2, what will happen with the I2? So this is the trend in the branch of the, this is at the I1. What will happen with I2, which is at the side of or at the branch of E2? At 15 volts, the current would be a little bit high. It is because the resistance at that side is low. And when the source was reduced, the current would expect there would be an expect decline in the current, or there is a decrease in source voltage. So this is the I sub 2. How about the I sub 1 and I sub 2 prime? You would follow the same pattern for plotting the behavior of the current in the circuit. And find out the effect of changing the value of the voltage source in a circuit.